Welcome to
Nay.
Do it.
Channel Everyone. This is episode 2020-60404. Okay, so today we are diving into a super interesting paper. It's about using large language models, not just to explain time series data, but to judge asterisk those explanations. JJ, you live in this world. Why is judging an explanation for a chart or a graph so tricky?
That is an excellent starting point, Isabel. The core challenge is, we have these amazing models that can look at a line going up and down and say, sales peaked in Q3 due to the holiday season. But how do we asterisk know if that's factually correct? The traditional methods, they fall short. You either need a perfect human-written explanation to compare against, which we rarely have, or you use numerical methods that can't read text at all. So we're stuck. We have no general-purpose referee for this game.
Exactly, it creates a trust gap. If an AI explains a spike in hospital admissions or a dip in stock prices, we need to know if that explanation is asterisk faithful to the actual numbers, not just plausible sounding. The paper proposes a clever workaround: use another LLM as the judge. You give it the raw time series data, the question, and a candidate explanation. It has to label it as correct, partially correct, or incorrect.
So it's like peer review, but AI on AI? That sounds meta, but also a bit circular, no? How do we know the judge is any good?
A very fair concern. To test this, the researchers built a synthetic benchmark. They created 350 different time series cases, with controlled patterns like seasonal drops or volatility shifts for each one. They wrote correct explanations, partially correct ones with small errors, and completely wrong ones. This gave them a clean test bed.
And then they ran two sets of experiments. First, they asked models to generate asterisk explanations from the data. The results were uneven for some pattern types, like spotting a structural break. Models were brilliant with 95% accuracy. For others, like a seasonal drop, they failed dramatically. Accuracy was near zero.
Whoa, so the models are great at some patterns and blind to others. That's a huge finding for anyone using them this way.
Precisely. But here comes the fascinating asymmetry. In the second experiment, they gave models the asterisk judge asterisk role. They asked them to rank or score pre-written explanations. And here, performance was much more stable and reliable. Even models that were terrible at asterisk generating a correct explanation for a seasonal drop could perfectly asterisk identify which explanation for it was right and which was wrong.
This is the key insight. The ability to evaluate factual grounding seems to be a more fundamental, more reliable capability in current LLMs than the ability to generate that grounding from scratch. The judge isn't just parroting its own biases, it's doing a discernible, consistent reasoning check.
So the takeaway isn't LLMs are perfect judges, but that this is a feasible, promising path forward. It gives us a scalable way to score explanations when we don't have a human in the loop.
Exactly. It opens the door to better evaluation systems, which in turn can help us train better generators. It's a step toward more trustworthy, data-grounded reasoning from AI.
And it highlights where the real problems lie. We now know to be very careful with certain query types. The research doesn't solve everything, but it gives us a much clearer map and a tool to navigate with.
Amazing. Thank you both for climbing that ladder with me. From what's the problem, to why is this solution clever, to what does it really asterisk mean? This is exactly the kind of nuanced discussion we love on AI Do It channel.
Thank you, Isabel.
Thank you.
And thank you for watching. See you next time.